Hello guys, hi all of you. So in this lecture video, we are going to discuss methods of differentiation. So already we have done one lecture on this topic where I introduced the meaning of derivative, geometrical meaning of derivative, and how to find the derivative from first principles for various standard functions. And I also derived the product rule, quotient rule, and also showed you about the chain rule. So all these things we have already discussed. So we can start off with a few problems on these topics. And before we start, let me have a small announcement. So guys, you can ace Unacademy Champion League for JEE and you can have a chance to win and get inspired by Sachin Tendulkar. So the aptitude test for this already happened on 18th and 19th. Now it's also going to be on 26th also, which was already conducted. So this kind of tests keep happening very frequently. So you can have the dates changed here, but the same test is conducted many times. So whenever it is announced, you can enroll for this test. Also, you have a lot of cash prizes here. And this is regarding the combat. And this is about the subscriptions. These are the various batches we have started. So let us get into the topic now. So introduction to derivatives, all this I already did. So I'll just show you what I've done in the previous class. So you can just see all these standard functions. We derived the derivative formulas and we just summarize them once. Also, we did rules of differentiation, including the product rule, quotient rule, and also the chain rule. So let us do few problems on this. So problems on basic formulae. You can just say we are going to do the problems on basic differentiation formulae. So you can say problems on basic rules of differentiation. So to begin with, let us start with this question. If y is equal to 1 plus x by factorial 1 plus x square by factorial 2 plus x cube by factorial 3 and so on up to x power n divided by factorial n, then what is the value of dy by dx? So the options are y plus x power n by factorial n. The third option is y minus x power n by factorial n. And the last option is y minus 1 minus x power n divided by factorial of n. So before I discuss this, I would like all of you to try this and then see the solution. So it looks like some infinite series in e power x, but we have only till x power n. So e power x could have been written if the same series is there up to infinite number of terms. But here it's only till x power n by n factorial. So this cannot be written as e power x. It's not e power x. E power x will be the series, but it's still infinity. So this is not e power x expansion. So how do we find the derivative? So normal differentiation only we can apply. So whenever you have sum of many functions, if you have to differentiate sum of many functions, you can differentiate each individual function and add them. So if you have to differentiate, let us write down the value of y as 1 plus x by factorial 1 plus x square by factorial 2 plus x power n by factorial n. So before you see the solution, you can just pause for a while, do it and then see the solution. So dy by dx, if you want, for 1 differentiation is 0. X will have a differentiation 1 by factorial 1. X square will have a differentiation 2x, so 2x by factorial 2. Next term will be x cube, whose derivative will be 3x square divided by factorial 3. Proceeding like this, the derivative of last term is nx power n minus 1 by factorial of n. So now you can write this as 1 by factorial 1 as it is. In the next term, factorial 2 is 2 into 1. If you cancel with 2, you will be left out only with 1. So you can write factorial 1, and this 1 factorial can also be obviously written as 1 also. And then you have x square divided by factorial 3 is 3 into factorial 2. So 3 will cancel out, you'll get factorial 2 here. Then we'll get x cube by factorial 3 and so on up to x power n minus 1 divided by, we know that factorial n is n into factorial n minus 1. This n will cancel out and you'll be left out with factorial of n minus 1. So now if you look at the series, you can see there is everything here which is there in the given expansion except for one term. So everything present in y is there except one term. This last term is missing. Everything else is there. Because the term before this is x power n minus 1 by factorial n minus 1. You can see there is everything here starting from here to here except the last term. So that last term is missing. So I can write this as last term minus x power n by factorial n. So the answer is therefore the third choice. Choice C is the correct answer. So it's such a simple question. You just have to know the derivative of the power function, that is derivative of x power n is nx power n minus 1. And another rule that you need to know is whenever you differentiate sum of many functions, you can write the individual derivatives and add up. So that's the problem. Now let's proceed to the next question. If y is equal to a sin x plus b cos x, then we need to find out the value of y square plus dy by dx whole square. So y square plus dy by dx whole square is the function of x. The first option is it's a function of x. The second option is it's a function of y. Then the third option says function of x and y only. And the last option, it's a constant. So once everyone can attempt the problem before you see the solution. So y is a sin x plus b cos x. You'll have to find out y square plus dy by dx whole square. So to do this, you have to know simple differentiation formulas. Like you know that sine has a differentiation cos, cos has a differentiation minus sine. We'll have to do based on that. So let us start with y equal to a sin x plus b cos x. So we know that the derivative of this is dy by dx equal to a into sine will have a derivative cos and cos will have a derivative minus sine. So that is dy by dx. And you wanted y square plus dy by dx whole square. So you just square and add them. So y square plus dy by dx whole square is equal to. So the first one you have to square, second one also you have to square and add. Squaring the first one will give you a square sin square x plus b square cos square x plus 2ab sin x cos x. With a plus b whole square formula I did squaring. Similarly, if you square the second one, it will give you a square cos square x plus b square sin square x minus 2ab sin x cos x. That is the expansion for second one. And you can clearly see that these two will cancel out and you'll be left out with this pair, which is a square, because sin square plus cos square will be 1 after taking a square common. And in this pair also taking b square common, cos square plus sin square will again become 1. So you'll be left out with a square plus b square, which is nothing but a constant. So the required answer is it's a constant. So therefore the correct answer is choice D. So that is the second question. I hope all of you understood the problem. Now let's go to the third question. If y is equal to x plus root of x square plus a square power n, then you need to find out the value of dy by dx. So let me write the options here. Ny by root of x square plus a square minus ny by root of x square plus a square. Let me write the third one, nx by root x square plus a square. And finally, the fourth option is minus nx by root of x square plus a square. These are the options. So given this function, how to find the derivative dy by dx? So once all of you can attempt the problem before I do it. So we have y equal to x plus root of x square plus a square to the power of n. Now, first of all, we'll learn this derivative. Whenever it is x power n, we know that the derivative formula is nx power n minus 1. But suppose instead of x power n, if the function is something like f of x power n, then we apply the similar formula n into f of x power n minus 1. But in addition to that, you also have to differentiate f of x into d by dx of f of x. How you have to differentiate. That is the conclusion from chain rule that we get basically. So if you have to write the derivative of this using the same rule, first n will multiply and then for this function power will reduce by 1. After that you have to differentiate the term inside, that is x plus root x square plus a square. This function has to be differentiated using this rule. So n into x plus root x square plus a square power n minus 1 will write as it is into differentiation of x with respect to x will be 1 and differentiation for root x is 1 by 2 root x. So we'll write 1 by 2 root x square plus a square. And we have to differentiate till we exhaust till the inner function. After differentiating root function, we have to differentiate this function. So x square will have derivative 0, a square will have a derivative, sorry, x square will have a derivative 2x and a square will have a derivative 0. So you get 2x here. Now cancel out this 2, it will reduce to n into x plus root of x square plus a square power n minus 1. And after finding LCM, the next term reduces to root of x square plus a square plus x divided by root of x square plus a square. So now you can see you have identical term in numerator, one with power n minus 1, other with power 1 here. So when you multiply both, the powers will get added. You will therefore get x plus root x square plus a square whole power n. Because the first one has a power n minus 1, second one has a power 1, they will add up and give you n. And root x square plus a square will be written as it is. But you can now see that this is nothing but the original function given. So you can write ny by under root x square plus a square. And this gives you the first option as the answer. So correct answer will be choice A. So you just need to be careful while applying the rule. So if you forget to write d by dx of f of x, you will get a wrong answer. So you should be careful in this kind of functions, f of x power n, this is the derivative rule. So I hope it's clear to all of you. Now let's proceed to the next question. That is question number 4. If y is equal to logarithm of tan x to the base sin x, then dy by dx at x equal to pi by 4 is equal to first option 4 by ln2. So normally ln2 is used when the logarithm has base as e. The second option is minus 4 ln2. The third option is minus 4 divided by ln2 and fourth option is none of these. Yes, all of you can now attempt the problem once. Yeah, so before we start off solving this, I'll write this result. Whenever you want to write differentiation of log, always remember when the base is e only, the formula is 1 by x. Otherwise, it is not 1 by x. You have to change. If the base is different, you'll have to do according to that. Already I explained this in the previous classes. So right now, when the base is, you can use this. And there is some property in log. If there is something like log a base b, you can choose any base of your choice and write log a base c divided by log of b base c. So these rules you can use in solving the question. So the question here is y equal to log of tan x base sin x. So we cannot apply the differentiation formula when the base is different. So first we'll change it to e. So write log of tan x base any number of our choice. So we'll take e. C is e here comparing with this formula divided by log of sin x to the base e. And once you convert into base e, it is of the form y equal to u by v. Then you can apply the quotient rule. So what does the quotient rule say? The derivative of quotient of two functions u by v equal to v du by dx minus u dv by dx divided by v square. So let us use the quotient rule in solving it. So apply the quotient rule for this. Then you can write dy by dx equal to denominator into v means denominator into differentiation of numerator into d by dx of log tan x. So let us write derivative of log tan x minus numerator into differentiation of denominator log tan x into differentiation of denominator, that is differentiation of log sin x base e divided by square of the denominator. So you can write by log of sin x base e whole square. So then let us write down the derivative now. So we can say dy by dx is therefore equal to log sin x into. So when you have to differentiate log function, normally I said you'll get 1 by x, but provided there is only x here. If there is any other function other than x, you need to differentiate that also. So for log tan x, first we'll write 1 by tan into, again you should differentiate tan x, for which you will get secant square x. Then minus sign. Similarly, you can write log tan x as it is and you have to differentiate log sin x. So if I write log tan x as it is, for log sin x, differentiation of log is 1 by sin. And again, the value inside the log is sin, whose differentiation is cos. divided by square of denominator is nothing but log of sin x base e whole square. So once you get the derivative, you wanted the derivative at x equal to pi by 4. So let us write down dy by dx at x equal to pi by 4. So put x as pi by 4, it will become log of sin pi by 4. So sin 45 is 1 by root 2. So log 1 by root 2 base e. Tan 45 is 1. So into 1 by 1. Secant square 45 is root 2 square, that is 2. Similarly, here you can say log tan 45, tan 45 is 1, log 1 is 0. So that will become 0. By again log of sin 45, log of 1 by root 2 whole square, you get. But since you have a similar term in numerator, when you cancel out, you'll be getting 2 divided by log of 1 by root 2 to the base e. Or you can also write this as 2 divided by minus log root 2 base e. Whenever you take reciprocal in logarithm, so it changes in sign like this. And root 2 is 2 power half. So you can also write this as 2 divided by minus of log of 2 power half base e. And using the property of logarithm, you know that power gets multiplied to the logarithm. So you can therefore write the answer as dy by dx equal to 2 divided by minus half ln2 logarithm to the base e. So you can write ln2. This 2 goes to numerator and you get the answer as minus 4 divided by ln2. And this is nothing but choice. So choice C is the correct answer for it. So that's how we solve this type of problems. Now let's proceed to the next question, fifth one. The differential coefficient of, we have to write down the differential coefficient of f of log x with respect to x, where f of x equal to log x to the base e is. So first option is x by log x base e. The second option is 1 by x into log x base e. Then we have the third option 1 by x log x base e. And finally the fourth option is none of these. We have to find the derivative of f of log x with respect to x, where f of x is log x. So let's see how we can do this. So f of x is given as log x, and you have to find the derivative of f of log x. So let the function f of log x be denoted by some z. You want to find dz by dx. So how do we differentiate this? So before you differentiate, it would be better to find the function f of log x is nothing but log of log x base e. And now you differentiate, it will be easier. So if it is dz by dx, so when you have a function inside a function, I told you in chain rule, first we'll start differentiating from the outer one till the inner one. So this log will have a derivative 1 by the value which is inside. So 1 by log x base e. Into further you need to differentiate this log also, for which the derivative is 1 by x. So you get the answer as 1 by x log x to the base e. So therefore you can say the correct answer would be choice C for this problem. So this question is quite simple. Now let's do the next problem. If sin y is equal to x sine of a plus y, then you need to find out the value of dy by dx. So the options are sin a divided by sine square of a plus y, sine square of a plus y divided by sin a into sine square of a plus y, and sine square of a plus y by sine square a. So this is the question. All of you can attempt this. And it's not always necessary that you will have to find out dy by dx directly. Sometimes you can also find dx by dy and find the reciprocal. So usually when y is given as a function of x, it is convenient to find dy by dx. But if x is given as a function of y, it would be more convenient to find dx by dy. So in this question, because you are given sin y equal to x sin a plus y, instead of simplifying this, you can write x equal to sin y by sin of a plus y. So since x is a function of y, rather than directly finding dy by dx, we will first find dx by dy and then write its reciprocal to get dy by dx. So apply the quotient rule. So what is dx by dy? Denominator into differentiation of numerator. So sine of a plus y into derivative of sine y, that is cos y, minus sine y into derivative of denominator. Again, sine will have a derivative cos of a plus y divided by sine square of a plus y. So I applied the quotient rule here. That is v du by dx minus u dv by dx by v square. After that, you can observe numerator is in the form of sine a cos b minus cos a sine b, sine of a minus b. So it will be sine of a plus y minus y. And denominator, let us write as it is, which is sine square of a plus y. So here we can cancel this plus y and minus y. And we therefore get the value of dx by dy as sine a divided by sine square of a plus y. So when you now find dy by dx, you get the reciprocal of this, that is sine square of a plus y divided by sine a. And this is nothing but choice B. So our correct answer is therefore choice B. So you can see that it's not always necessary that you have to directly find dy by dx only. In some questions, wherever x is a function of y, we can always calculate dx by dy and then take the reciprocal in order to get dy by dx. Let's move on to the next question now. The value of d by dx of modulus of x minus 1 plus modulus of x minus 5 at x equal to 3 is. So the options are -2, 0, 2 and 4. So in this problem, we'll see how to find out the derivative for functions involving a modulus. So when you have a function such as this, which has a modulus, I'll write this as y equal to mod x minus 1 plus mod of x minus 5. Solve it. So if you have to find the derivative, first you can split the function into parts. How do you split the function into parts? So whenever you have combination of mods like this, you can just draw a number line where each mod becomes 0. The first mod becomes 0 for 1 and the second mod becomes 0 for 5. Mark the points where these mod terms become 0, arrange them on the number line. And based on this, you make partitions. So like this, you draw lines and you have 3 partitions here. So x can be before 1, x can be between 1 to 5, after 5. So there are 3 cases. So we'll be writing x less than 1, x is between 1 and 5, x is more than 5. There will be 3 cases such as this. And equal to sign you can put anywhere for 1, like I'll put here and here. So when x is less than 1, so if x is less than 1, obviously it is less than 5 also. Anything less than 1 is also less than 5. So both x minus 1 and x minus 5 are negative. So here both x minus 1 and x minus 5 are negative. Therefore, you can, when you open the mod, what is the definition of mod? When something is positive, mod x is x. If it is negative, mod x is minus x. So when you open the mod, you have to write negative for both, because when x less than 1, both are negative. So when you open the brackets, it is giving you minus x plus 1 minus x plus 5. So it is minus 2x plus 6. 6 or 4? 6 only. So now what is the derivative in this case? So you can say derivative in this case is minus 2. So before 1, the derivative is minus 2. If x is between 1 to 5, you know that x minus 1 will be positive. So first mod will open with a minus, but x minus 5 is negative. So second mod will open with a minus. So this will give you x minus 1 minus x plus 5. And in this case, you are getting the answer as 4. So derivative will become 0. In this case, derivative is 0. And last case, if y is equal to x is more than 5, both are positive. So when you open the mod, both will have a plus sign. And that will give you y equal to 2x minus 6. So if you write down the derivative, it is actually giving you 2. So among all the answers, all the 3 are correct, but they ask you the derivative at x equal to 3. So 3 belongs to this interval. So because x equal to 3 belongs to this interval, your answer has to be derivative equal to 0. So you have to mark the answer as dy by dx equal to 0. That is choice B is the correct answer. So B should be the correct answer. So we can skip writing 2 cases, but I wrote all the 3 so that it will be in more detail. But when you actually do the problem, in the neighborhood of 3, close to 3, for example, it's between 1 and 5 only. You can check only case 2 and you can skip 1 and 3 because you wanted only for 3. So you can save some time in doing objective questions by neglecting the other cases. What is relevant to the question, you can just do that part. Now let's move on to the next question again. let f of x is equal to square root of x minus 1 plus square root of x plus 24 minus 10 root of x minus 1. So this is the function given where x is between 1 and 26. So you can say this is a real valued function, be a real valued function. Then you need to find out f dash x for 1 less than x less than 26 is. So the options are again 0, 1 by root of x minus 1, 2 root of x minus 1 and none of these. So if you are not careful about finding square root properly, you will get a wrong answer here. So we should know how to find the square root of the second one. So before you solve that, we'll first find the square root. So what is the function given? Root of x minus 1, I will not change this. The second one, I'll show you how to find the square root first. So whenever you want to find out the square root of a third like this, what you need to do here is, I'll just calculate it separately. So square root of x plus 24 minus 10 root x minus 1. If you want square root of any third, see that before the square root, the number is 2. So write that as x plus 24 minus 2 into, you will get a 5. Bring that inside the root. 5 square is 25. Because after taking square root, it has to be 5. Inside it should be 25. So then you can see that when you multiply 25 and x minus 1, you will get the factor required. But adding them will give x plus 24. So I can just say that x plus 24 can be written as sum of these factors. So 25 plus x minus 1 minus, you can split this as 2 root 25 into root of x minus 1. So this will now change as 25 is 5 square and x minus 1 is root x minus 1 whole square minus 2 into 5 into root of x minus 1. Now when you write the square of this, it is of the form a square plus b square minus 2ab. So within the root, you can write its value as under root of 5 minus root of x minus 1 whole square. You can also write root of x minus 1 minus 5 whole square. So therefore, when you take square root, better you write a modulus. And when you open the mod, whichever is bigger, we'll write that first. And to decide that, they gave a condition in the question that x lies between 1 and 26. So if you are using that condition that x is between 1 and 26, subtract 1, it will give you x minus 1 is between 0 to 25. And taking square root, x minus 1 is between 0 to 5. So that means 5 is bigger. So therefore, when you open this modulus, you can open this writing. So you can open this writing 5 first. So when you open the modulus, you have to write the term 5 first. 5 minus root x minus 1 because 5 is bigger. So in the function f of x, we can therefore write root x minus 1 as it is. And the square root of the second third, you got 5 minus root x minus 1. So instead of 5 minus root x minus 1, if you are writing root x minus 1 minus 5, obviously you will get a wrong answer. And that will also be there in the options. So you should be careful in evaluating this. Then you can cancel this. You get the function as f of x equal to 5, which is a constant function. So derivative of this is f dash x equal to 0 because differentiation of a constant function is always 0. So this was also quite simple. Right. Now let me do the next question. If f of x is equal to modulus of sine minus mod cos x, then the value of f dash x at x equal to 7 pi by 6 is, options are positive, 1 minus root 3 divided by 2 and 0. Also you can write none of these. So let's see how we can solve this. This is also again a question of mod. So when you open the mod, you need to be careful about this. X equal to 7 pi by 6 is nothing but 210 degrees. It is in third quadrant. In third quadrant, sine and cos are positive. So let's see how we can proceed for this. So x equal to 7 pi by 6 is given. This is in quadrant 3. So if that is in quadrant 3, you know that sine is negative and cos is also negative. So when you write the function f of x, first we'll open the inner modulus, keeping the outer mod as it is. Cos is negative, so make it mod cos x as minus cos, so it will become plus. Now after you get this again, if sine and cos are negative, you know that the sum is also negative. So if the sum is negative when you open the mod, you can directly write this as minus of sine plus cos. And if you now differentiate this, you'll get f dash x equal to minus of sine will have a derivative cos, cos will have a derivative minus sine, minus of cos minus sine or sine x minus cos x. Now, if you want f dash of 7 pi by 6, you can put x equal to 7 pi by 6 here. That will give you sine of 7 pi by 6 minus cos of 7 pi by. So let's see what is the value now. Sine of 7 pi by 6 is sine 210. And what is sine 210? Sine of 180 plus 30 minus sine 30. So minus of. And this is cos of 210. So cos of 180 plus 30 minus cos 30. So it will become plus cos 30 is root 3 by 2. And you see it is root 3 minus 1 by 2. Root 3 is more than 1 because root 3 is 1.732. So it is positive. So the answer is therefore choice A. So based on the neighborhood of this point, we have opened the mod here. You can take cases, but whenever they give a particular point, you can always do it according to that. Now let us take up the 10th question. If f of x is equal to modulus of x square minus 5x plus 6, then you need to find out the value of f dash of x. So the options are 2x minus 5 for 2 less than x less than 3. Then 5 minus 2x for 2 less than x less than 3. Then we'll be writing 2x minus 5 for 2 less than or equal to x less than or equal to 3. And 5 minus 2x for 2 less than or equal to x less than or equal to 3. So you can see some options look identical, but in second and third option, 2, 3 are not included. In the last one, 2, 3 are included. Likewise in first and third. So therefore, when you answer it, you should be very careful about this. So remember, whenever you are given a function with mod like this, when you factorize the term inside the mod here, anyway, it is giving you x minus 2 into x minus 3. So where this mod becomes 0 at 2 and 3, at such points, it will not have a derivative. So whenever this mod becomes 0, so you can say that x equal to 2 and 3, modulus becomes 0. Mod becomes 0. So at such points, usually derivative is not defined. So 2, 3 will not be there in the interval. So we have to check for other case. So anyway, while checking for this, when x is between 2 and 3, you know that x minus 2 is positive and x minus 3 is negative. So overall the product is negative. X minus 2 into x minus 3 is negative. So when you open that bracket, you can write that as minus of x square minus 5x plus 6. So when you write down the derivative, you will get an answer of minus of 2x minus 5. And that is equivalent to writing 5 minus 2x. So you can say derivative is 5 minus 2x, but you have to mention that x is between 2 and 3 because the derivative at 2 and 3 will not be defined. So we'll discuss this in more detail when we discuss differentiability chapter. But just right now you can remember whenever there is a mod term where the denominator becomes 0 at such points, the derivative will not be defined. For this kind of terms, when the mod becomes 0, it is not defined. So this is because when you write derivative of mod x, you can also write mod x by x. So when x is 0, it will be 0 by 0, indeterminate. Or if it is derivative of some mod f of x, you can also use this rule also. It will be mod f of x by f of x multiplied with f dash x. And of course, if f of x is positive, this mod f of x will be f of x and you'll get the ratio as 1. And if f of x is negative, you'll get that ratio as minus 1. So you can get two answers. But remember, again, f of x is 0, the derivative will not be defined. So for f of x equal to 0 here, d by dx of mod f of x is not defined. So this is the rule I applied earlier. That was question number 10. Now let's proceed to the next question. Question number 11. If y is equal to sin x plus e to the power of x, then you need to find out the value of d square x by dy square. So let me give you the options. The first option is minus sin x plus e power x whole power minus 1. The second option is sin x minus e power x divided by cos x plus e power x whole square. Then we have the third option, sin x minus e power x divided by cos x plus e power x whole cube. And the last option that we have, sin x plus e power x divided by cos x plus e power x whole cube. So here we are going to find the second derivative. But before we solve the question, let me explain more about the second derivative. So when you are given y equal to function of x, you are finding dy by dx already. So what is the meaning of d square y by dx square? Whenever y is a function of x, you can easily find this. The meaning of this is d by dx of dy by dx. After finding the first derivative, if you differentiate again with reference to x, it is called second derivative. But what is the meaning of second derivative d square x by dy square? After finding dx by dy, if you differentiate again with reference to y, that is called d square x by dy square. So we are supposed to find out the second one here, d square x by dy square. So let us start with the given function sin x plus e power x. But when y is a function of x, it is more convenient to find dy by dx. So no issue. First we'll find dy by dx only. And then we'll see how to find this value. So the sin has a derivative cos, e power x will have a derivative e power x. After that, for finding d square x by dy square, I wanted dx by dy. So just write the reciprocal of this. You will be getting dx by dy as the reciprocal of this 1 by cos x plus e power x. So you can also write this as cos x plus e power x whole power minus 1. And if you differentiate this with reference to y, you can get d square x by dy square. So d square x by dy square equal to, when you're differentiating this, it is in the form of f of x power n. So write n into f of x power n minus 1. So minus 1 into cos x plus e power x power n minus 1 means minus 1 minus 1 minus 2 into derivative of cos x plus e power x with reference to y. So remember, it's not derivative with reference to x now, it is with reference to y. So d by dy of this. So we can also write this as minus 1 divided by this whole power minus 2 numerator is equivalent to writing square in the denominator like this. And for differentiating this cos x, you can write minus sin x. For differentiating, you can write e power x, but you cannot leave it here because the variable is not the same. The variable of differentiation is y, but the variable inside is x. So we'll have to write dx by dy. And already you know dx by dy value. You can just put it back here. So we can just bring the minus sign inside. It will become minus of minus plus, minus of plus minus. So sin x minus e power x divided by, we already have cos x plus e power x whole square here. You can also substitute the value of dx by dy in this. I think it would be better if I write this in the next page. This part, let me write in the next page. So we have got d square x by dy square equal to minus 1 divided by cos x plus e power x whole square into, so what was the term left out there? D by dy of cos x plus e power x, which is minus sin x plus e power x into dx by dy. So now just bring this minus inside. It will become sin x minus e power x divided by cos x plus e power x whole square. We'll write it as it is. Multiplied with dx by dy is 1 by cos x plus e power x again. Is it plus or minus? Let me check. So what is the value of dx by dy? Cos x plus e power x whole power minus 1. So writing this, it will give you the answer sin x minus e power x divided by, multiply these two terms of denominator, you will get cos x plus e power x whole cube. So this is nothing but choice C. So this problem illustrates how to find out the second derivative. There is y square here, of course. Then the next question, which is more similar to this, if y is equal to x plus e power x, you need to find out again d square x by dy square. So the options are e power x minus e power x divided by 1 plus e power x whole cube minus e power x divided by 1 plus e power x whole square and minus 1 by 1 plus e power x whole cube. So these are the options. So this is also quite similar to the previous question, and let's do it. So y is x plus e power x. So differentiate this, you'll get dy by dx equal to d by dx of x is 1 and d by dx of e power x is e power x. So therefore, what is dx by dy? The reciprocal of this, 1 by 1 plus e power x. Or you can also write 1 plus e power x whole power minus 1. Now, in order to find d square x by dy square, you differentiate this again with reference to y. So when you differentiate this with reference to y, first you write x power n derivative formula n into f of x power n minus 1, that is minus 2, into d by dy of 1 plus e power x. So that will give you minus 1 by 1 plus e power x whole square. And derivative of 1 is 0, derivative of e power x will be e power x into dx by dy. For dx by dy, you can put this value. So d square x by dy square equal to minus of e power x divided by 1 plus e power x whole square into dx by dy, you can write 1 by 1 plus e power x. So that will give you an answer minus of e power x divided by 1 plus e power x whole cube. And that's nothing but choice B. So this question is almost similar to previous question, and this is quite simple also. So let us do a few more problems. Just 2 problems are left on this topic. We'll just finish that and conclude this topic. And in the next class, we can start off with a new topic, that is the derivative of composite function and inverse functions. So here we have 2 questions left. Let us finish that. If sin x into cos y is equal to half, you need to find out the value of d square y by dx square at pi by 4 comma pi by 4. So the options are minus 4, minus 2, minus 6 and 0. So there is something called implicit differentiation which you'll learn later. So we'll not use that concept here. We'll do directly here. So sin x into cos y is half. You want second derivative of y with reference to x. So what we'll do, whenever you are given in the form of equation like this, we can do the differentiation straight away applying uv. So sin into derivative of cos y is minus sin y dy by dx. Then write cos y as it is. Differentiation of sin x is cos x equal to RHS will be 0. So this will give you minus sin x sin y dy by dx minus sin x sin y dy by dx equal to the other term cos x cos y, you can bring it to RHS, it becomes minus. So cancel minus on both sides. And when you divide, you'll get dy by dx equal to cot x into cot y. So what is dx by dy? You wanted second derivative with reference to x only, no? Okay. Then you don't need to find dx by dy. So for finding d square y by dx square, again you apply product rule here. So cot x into derivative of cot y is minus cosecant square y into dy by dx. Because the derivative is done with reference to x. Plus, right, cot y as it is, derivative of cot x is minus cosecant square of x. So after doing this, you have to substitute the limits. So when they ask you second derivative at some point, so you'll have to find the derivative, then substitute. Don't substitute before differentiating. If you substitute before differentiating, you'll always get 0. So that's not correct. After finding the derivative only, the value that is given has to be substituted. So if you put pi by 4, cot pi by 4 is 1. And cosecant square pi by 4 is root 2 whole square 2. Into you'll have dy by dx at pi by 4. So let us just find out what is dy by dx at pi by 4 to use it here. So when you want this value at pi by 4, you know that it is cot pi by 4 into cot pi by 4, that is 1. Put that here, it will give you 1. So that is 1. Again, you have cot 45 here, which is 1, minus of cosecant square 45, which is 2. So we'll get minus 2, minus 2. So the answer is therefore minus 4. So that means choice A is the correct answer. Now, one last question for this topic. If y is equal to x into log of x by a plus bx, you'll have to find out the value of x cube into d square y by dx square. So the options are x dy by dx minus y, x dy by dx minus y whole square, y dy by dx minus x, and y dy by dx minus x whole square. So let's see how we can solve this problem. So you want second derivative and the answer should be written in terms of first derivative. So y is equal to x into log of x by a plus bx. Either we can convert in power of e or we can do directly also. But when you do directly, we can just open this log, because log of m by n is log m minus log n. You can write this as log x by c minus log of a plus bx to the base e. So now you differentiate, you'll get dy by dx equal to, I think instead of directly differentiating, you have to apply uv there. I'll bring it to denominator, it will be better. So before you differentiate, what I'm going to do here is you write this as y by x first. Write down the value of y by x equal to log x minus log of a plus bx. So now we don't need to use uv in RHS, but you have to use u by v in LHS. So if you differentiate both sides with reference to x now, so when I write derivative of y by x, it will be x into dy by dx minus y by x square by using the quotient rule. For RHS, when I differentiate, log x will have derivative 1 by x and log of a plus bx will have derivative as 1 by a plus bx into derivative of a plus bx will be b. So write b there and simplify it. So this will give you x into dy by dx minus y equal to x square will multiply to the right hand side. And after finding LCM, you will get a plus bx minus bx by x into a plus bx. So here this bx cancels out and one x also cancels out. You'll get ax by a plus bx. So let me just write that in the next slide. So x dy by dx minus y, we got ax by a plus bx. So call it as equation 1. So we want the answer in terms of this term only. So we'll use this again. So keep it as 1. I'll use 1 again. But now because you want second derivative d square by dx square, differentiate this both sides with reference to x. So if you apply the derivative here for x dy by dx, we'll apply product rule. So we'll get x into derivative of dy by dx is d square by dx square. Then write dy by dx as it is. Differentiate x again. You'll be getting 1 for this with product rule for x dy by dx minus second derivative of y will be dy by dx. And for differentiating RHS, use quotient rule. So we'll get a plus bx into derivative of numerator, that is ax derivative is a, minus numerator into derivative of denominator. A plus bx will have a derivative b only. By square of denominator is a plus bx whole square. So in LHS, cancel this, you will get x into d square y by dx square equal to, in RHS, when you open the brackets, abx and abx will cancel, you are left out with a square by a plus bx whole square. And you can see you have a similar term in equation 1, but there is x here, there is no x here. And you also wanted d square by dx square into x cube. So when you multiply with x square, it will give you x cube into d square by dx square equal to a square x square by a plus bx whole square. And clearly you can see that this is nothing but square of the first one. This term only square. So I can therefore write x dy by dx minus y whole square, and that's nothing but the second choice. So choice B is the correct answer. So guys, so right now we finished all problems related with basic rules of differentiation, like derivative of sum or difference of functions, derivative of product of functions, derivative of quotient of functions, and also the chain rule. So all these things we have discussed the concepts and we have also done the problems. And chain rule also be used in some of the questions, of course. So in the next topic, we are going to discuss, that is the third lecture of derivatives. We are actually going to see how to find the derivative of composite functions and derivative of inverse of a function. So I hope all of you like the class. Thank you so much. Let's meet in the next class. Bye all of you.